Hello everyone, this is Dan Blanchette, and we are taking a look at a work in progress here, which is my cell calibration program. So this is going to set a threshold based on researcher inputs. So whatever images you have, whatever color range you're working with, we're going to take a few samples from whatever image you're doing research on, and we're going to go ahead and average those values for that color channel. And that will then be applied to the cell counter program, which will allow your cells to be recognized by the computer. So here's what we have so far. We have some CSV files with some data in them. At this present time, I don't have any guard code to not erase the file when we begin a new run of this particular program, but rest assured, it's going to come in later. This is all in testing phase right now. So what it's going to do is erase these values instead of preserving them. In the future, we're going to have a way for you to store the calibration from last session or begin a new calibration based on your imaging, because not all images are equal and not all color channels are used I guess, universally across the spectrum of the imaging that you're going to be dealing with. So let me give you a quick run through of this. So what we're going to do is we're going to go ahead and run this program with Python 3 getrgb.py, and that's going to pop up another window. So I'm going to take a quick peek at that. So this window is the one that's being generated right now, and it is of our zebrafish image. And you can see down in the bottom left-hand corner here, we have RGB values and coordinates on the X and Y axis, which is pretty awesome. Now let me change things around here a little bit. There we are. You can actually see things a bit better. All right, so that having been said, now we have a way to look at this image in all its glory. We can even come all the way in. Let me get on a cell here. And this is something you may have noticed from my poster presentation if you were there. Um, we have Jupyter Notebook to thank for this, but this is all the metadata this image possesses on the red, green, and blue channels. And as we observe, the closer it is to the lime green, the more it fades out. And the further away it is, the more it becomes apparent to us, and the value begins to decrease. So, that having been said, as we pull back out, it's important to keep in mind because we have CSV files here that are now blank, and we're going to go ahead and click about 2 to 3 times here and generate some data. So we'll go here, click here. Let's grab this one, and maybe, oh, there's a darker one over here, so let's see what that is. Okay, so now we're going to hit escape to close this window. We're going to go back to VS Code, there it is, and we're going to see that, oh look, it ended up generating some coordinates for us, the tuples of what just got recorded, and of the red, green, and blue channels, of course. And we're going to also see that we have the data outputted to these CSV files. This is important because I'm writing a read CSV program right now, which works. I've got it to work. The next thing is to take all the data it's going to read and store it in, store each value separately in a function so that we can average those values from that particular file. So that's kind of the next step. Apply a little statistical math to it and get a mean. Once that happens, we'll be able to take those variables and have an end calculation variable, rather. That's what I'm trying to say. Getting a little tongue-tied there. And that end calculation variable will plug back into the threshold logic from the cell counter program that's already been discussed in a previous video. And that will be approximately what your threshold should be for that particular research, and start counting the cells the same way my program does right now in terms of the zebrafish image. Of course, this will have other implications where you can as the user maybe have a little bit more manual control, you can come in and edit the program if you're savvy that way and change the value if the threshold seems to be just a hair off. Or we can apply other methods in the future that look at that particular process and say, no, actually it's closer to this, or no, it's actually closer to that, and do some evaluation. But that requires a more sophisticated approach. And as with things, the more complicated things become, oftentimes there's more room for error. So at this point, that's what this calibration program does. I hope you got a kick out of seeing what it's capable of doing. And thank you for coming by and checking out the poster, spending your time with me on this YouTube channel. For more information and the actual source code to this open source software, check out the comment section below. I will have a link posted to it. And thank you for watching.